Okay, welcome to today's webinar. The topic today is analysis of steel joints using FE model in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, the customer projects, the German and English webinars, etc. I will be the moderator today and also the presenter, and my two colleagues will support me, but they can introduce themselves.
Hi, my name is Walter Fröhlich. I'm responsible for customer support and I work in a team on the product development of steel joints. Today I will answer to your questions in the chat.
Yeah, hello, my name is Lucas. I work for Dlubal for 11 years and I'm working in the quality management department with the focus on the interfaces and the steel design. And I will also answer these questions in the chat.
Okay, then also additional information from my side. I've been working for the company for 12 years and the same is valid for Walter. Okay, then thank you again for your introduction. Then we switch off our webcams that the attendees can see the full screen. You can ask questions via the control panel on the right side of your screen. You can enter a short question here and my two colleagues will answer you. If you don't get an answer during the webinar because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email questions to info@dlubal.com. To the content today, I will define steel joint components using the library, and then I will define steel joints using components, a flexible modeling of a joint. Okay, then the structural analysis. I described the analysis settings and so on. And I evaluate the results. For example, I take a look at the submodel and the formulas and so on. Okay, then I turn to the program, RFEM 6. A simple model, a framework, frames in that direction and bracings in that direction, in the X direction. We have got several load cases, for example, the self-weight load case, then the imposed load, two wind load cases, one in X direction and one in Y direction. And we have got several combinations and a design situation. So, okay, to design the steel joints, I have to activate the add-on here, left above, under base data. I open the dialog and then under add-ons, it's already activated. It's from my test. And the standard is also already here for the load case classifications and the standard and national annex, in that case for Germany, for the steel joint design. Okay. Then if the add-on is activated, there are two new folders here, the types for steel joints, for the creation of the steel joints, and at the bottom, the steel joints design, the design situations, and ultimate configurations. I will show you that components that component, the ultimate configuration, in the next dialog. But before I do that, I go to the design situations. You can see again the load cases here, the actions, and the design situation. And it's important, if you activate the add-on, it's the default setting that it is activated, the steel joints design. Just note that it is here. Okay, and then those are the action combinations and the load combinations. And those load combinations are included in the design situation. You can see that here in the overview. Okay, so we can leave the dialog and start with the first steel joint. Maybe I can show you that in the model. I would like to use that node here, and I will define all connections for that node. The rigid connection of the steel frame and the pin connection or connections of the platform beams and the two connections for the bracings. Those are L sections. Okay, let's start. Right-click on steel joints on the left side in the navigator data, and I select new steel joint. First, I select the joint, the node, sorry. Okay. Node 33, and I apply that. There are 7 members that have got the end or the start point in that node here. We can click through them. Member 1 is the platform beam. That's the bracing, the frame or the horizontal beam of the frame, the upper column, the lower column, the other platform beam, and the upper bracing. Okay, here you can see the design configuration. I open it. You can perform a buckling analysis. Then you can see the standard settings here, the maximum number of iterations. You can increase that, for example. Then you can also increase the number of load increments. That's the standard setting, limit plastic strain. That's the value from the standard. And so on. I leave all settings as they are, also the safety factors here. If you want to perform a buckling analysis, you can go to that dialog. You can also increase the number of lowest eigenvalues, number of iterations. That's the limit load factor from the standard. It's 15 according to the Eurocode. Okay. And that for that connections, I don't do a buckling analysis. Okay, then we go to the next dialog, members. The finite element analysis requires at least one member to be supported. I select the lower column. The column is in reality supported here, and I will support at least this column. Okay, and we define also that the column is continuous. That's automatically overtaken for the two columns. So the member settings, you can see here the member settings from RFEM S235, and the sections, and we overtake the sections, of course. So then under components, you can use the library and you can create single components. I open it. You can see 4 categories. The modifications, member cut, plate cut, we will use both of them. Then the plate editor, plate, stiffener, haunch, and so on. Then under connection elements, end plate, fin plate. under others, the auxiliary plane, a help plane, then the welds and the fasteners. Yeah, that's the current state of that library. We will extend that library continuously. A team of 8 members or employees are working on the development of the add-on steel joints. We also extend the templates. I go to the template library. So there are also 4 general categories: the rigid connections, the pinned connections, truss, and the bracings. I click through some examples: beam to beam, beam to column, with haunch, such a connection. If you download a trial version or you already bought the program, you can click through the single components. Maybe cross joint. Okay, I will show you some pinned connections: beam to beam with cleats, thin plate, short end plate, beam to column, the same, cleats, thin plate, short end plate, and so on. Trusses, you can use that for diagonals or for bracings. The key joint, welded, such a connection. Also for bracings to use welded, it's quite new. The rectangular cross sections with a weld, T-joints, X-joints, and so on. Then last but not least, the bracings. Similar connection, such a connection. Okay. But we will start with the first connection, the rigid connection. I use here the category rigid, beam to continuous column, and this one, with a haunch and column stiffness. If I apply the template, we will see it in the preview here right at the bottom. And you can see we have to modify that connection. We leave the dialog with OK. And we go through the single components. So I extend the window a little bit. Okay, so then we start with the end plate. Member 3 is okay. You can see member 3 is selected if it is chosen. Then the reference member is the column. You can see it's selected. We use a thickness of 15 millimeters. Then 210 millimeters. Left offset. We don't need an offset. We say 0. Okay. On the other side also 0. The rest is quite okay. So then the balls, we use a diameter 20 millimeters and a screw strength of 10.9. So then you can use our values here. It's quite okay for this connection. I will only change the vertical spacings. I use only 3 bolts. Okay, and I only I entered the first 3 values. 70 space 95 space 150, and the last dimension is calculated automatically. Okay, then double filled welds for the flange, 6 millimeter, then 4 millimeters, and also 6 millimeters. Okay. Now, but you can see we have to modify the haunch. That's the next step. So member number 3, that's okay. So then plate is also okay, and plate 1, that's okay. So the other values are also quite okay. I decrease that value. Okay, and you can see now it's okay. So then I have to define a material for the flange. We use also the 235 steel. So then the width, can be larger, 200 millimeters in that case. Okay. So then the welds, that weld here, you can see it's selected, 4 millimeters. Now we can leave the double filled weld. Then this weld also, the double filled weld, 4 millimeters. Then plate to flange. This one, also 4 millimeters. So then the flange extended member. Now this is this one. We use another weld, a butt weld rear side. And for this flange to reference, this weld, we use a double filled weld. Okay, and 5 millimeters. Okay, so the haunch is quite okay, but the stiffness not. So that stiffener should be quite okay. Let me check the values. Yeah, okay, I only define a weld of 4 millimeters. But we have to move the upper stiffener here. So the value is minus 400. Okay. And I've also to change the weld. Okay, the rigid connection is finished. And yeah, it would be possible to save it as a template, for example, to use it for the other rigid connections for the frame, for example, on the edges of the framework. And then you could press that button here, save component as template. You can give it a name, select the category and subcategory, and so on. Okay. I don't do that. I continue with the connection of the platform beam, of that beams here. So that's why I use a component at the end, an end plate, this one, end plate. So connected member is member 1, this one. And the reference or the other connected member is the member on the opposite side. It's member 6. And the reference member is the column, that's are the members 4 and 5. Okay, now you can see the end plate. So same material. I decrease that value here. Now we don't want to connect the flanges. Also on the lower side, -20. Okay, the rest is quite okay. The opposite plate should be the same. It's on this side. Yeah, you can see it here. Okay. So then bolts M12, it's okay. 4.6 as screw strength, it's also okay. Then I enter the value 20 and the rest is calculated automatically. So then I use also 2 vertically and enter the value 35. That's good. So then we turn to the welds. We don't connect the flanges. Yeah, that's why we deselect our flanges. Only the 2 webs should get a double filled weld. And the value is 4 millimeters. Okay. So, and now the 2 end plates are finished. Not yet, sorry. We have to add a cut here. Yeah, it's in conflict with that plate here, with the plate of the rigid connection. To have gotten better overview, here with that button here, right at the bottom, I deselect the member number 7. Okay. Now it's better to see, I think. So I add a member cut. Which member? Member 1 by plate. And cut via stiffener 1, plate 1, that one here. Okay. So face with an offset of 15 millimeters. And now you can see the cut. Okay. To have it on the opposite side, I can copy that. That's also a new feature. By right-click, I copy the components at the end, only this one component. And I have to define another member. In that case, member number 6, the left side. And the cut is via stiffener 1, plate 2. So you can see it. So now the rigid connection is created and also the pinned connections, and we continue with the bracings. I select number 7 Okay, I can close it to have a better overview. So, yeah, since we've got this component that I want to use in the library, I have to create it with the single components. Yeah, it's a little bit more complicated, but you can see now that it's very flexible. Yeah, you can define almost all connections with the single components. So I start with a plate, stiffening elements, plate. So the material is S235 again. The thickness should be 8, then 250 and 170. And the position should be a member plate. So, and that's the member number 7 and the leg 1. And you can see it in the preview on the right side. Okay, but I have to move it a little bit. I use 250. Okay, and to have it on the side of the leg, I enter here -8. Yeah, that's the offset of 8 millimeters. Yeah, and you can see now it's not in the axis of the platform beam. Yeah, that's the difference between the static model, and the connection model. Yeah, the axis of the L section is here, and the axis of the horizontal beam here, and the plate is now has an offset. Yeah, you can avoid that if you define an eccentricity for the bracing in the RFEM model, or you can ignore it for the steel joint design. I ignore it for the steel joint design. It's up to you how to use it. That's the difference between the axis model in RFEM and the detailed connection model. Okay, the plate is not finished. We have to enter cuts. I enter this plate cut. Yeah, the plate is number 1. By member plate. Cut wire, I select the column, and the web of the column should be the reference point. Okay, the rear side, closer end is the cutting plane. So we can do it step by step. No, that doesn't. It doesn't take the plate number 1. Okay. You can do it step by step, or calculate which is the right place. I would like to have the plate cut here at the end of the member cut, and that's 120.25. Okay, this cut is quite okay. We enter a new cut. So again, plate number 1 by member plate. That's the same again. Member 4 and 5, and the web. That's the reference point. Front, the closer end, and I enter minus 335.25. Okay. Only one cut is missing. Plate cut. Again, plate 1. So now by member plate. And this time member number 1. You can see it selected. And the upper flange, flange 1. Okay. The rear side. Yeah, and that's all. I only have to enter a double filled weld of 4 millimeters. So now we have to cut the member. Yeah, you can see it's in conflict with the other parts of the connection. So I enter the next component. Here left above a member cut. The bracing is the member number 7. By member number 1. That's the platform beam, yeah, the horizontal beam. Then shouldn't be parallel but perpendicular. And a small offset. Okay. So now we have to define the bolts, means fasteners. I add the component fastener. The component is member plate, member 7, leg 1. The other component is the plate number 1. So that's okay. M12, I use another screw strength. You can decide by yourself. I, for example, use 8.8 this time. So, and that's the distance from the crossing here. 300, then space, and the distance between the screws or bolts should be 40. And that's all. And now the connection for the upper bracing is finished. For the lower bracing, we use the same function. I copy that. So I copy the last 6 components. I select all. Then I do right click and copy components at end. So now it's the same, the same connection, and I have to modify it. So that's plate number 2. I start with plate number 2. So I only define here another value, member plate, but this time another member. The member number 2, the upper bracing, and leg 1. I hope you can see that it is selected. Okay, then that values are almost okay. 90. Okay. So then plate cut 4. I use another value. Yeah, you can see the 45 millimeters are okay for this connection here. Plate cut 5. That's also okay. Minus 265. And only this plate cut here, the flange is missing. Flange number 2, the lower flange. Then the front side. Well, and that's all. So then the member cut, I rotated a little bit, but you can see all. This time member 2. Yeah, and that's all. Only the fasteners needs to be modified. Member 2, leg 1. So, and 200 space 40, and that's okay. So you can take a look if everything is okay, and you can do a plausibility check. Yeah, no errors found. Now that's quite good. Okay, I leave the dialog, and you can see the connection in the preview. If this button here right above is activated, you can also activate no joint model or simplified joint model. Now I will use that. So, and now I can also use that connection for the other 3 nodes here. So I can, for example, open the dialog by double click on the connection, and I can select the other 3 nodes. Okay, so I apply it. And now we have got 4 connections, 4 similar connections. So then we can open in the table here the steel joint design. And if I press that button here, the calculations would start. I skip the calculation. Yeah, the calculation time is about 15 minutes on my computer. I skip the calculation time and I open the calculated model. I open the panel. So, and you can see the ratios here graphically. That's the connection with the highest ratios. I go through the table, steel joints, stress strain analysis. You can see the design ratio by design situations, by loading, by joint, by node, by components. Okay, if you go, for example, in that line here and open the design check details, then you can see all formulas from the standard for the bolts, also the formulas where you can find the formulas in the standards, and so on. You can also switch between the designs here, plate, weld, the welded design, and so on. Okay, then when you click that button, the results in steel joints, you can see the detailed model. So it's the whole connection. You can see the ratios here graphically. The gray area is a new feature for values that are not from interest, with, for example, very small values. You can click through the single components, deselect, for example, the members and plates. Now we see, for example, here the welds and the maximum design ratios. And you can go through all. So then you can save that submodel here with that button left at the bottom, and you can open it. And that's the submodel with surfaces, the supporting of the column, horizontal beams as surfaces, the bolts, the welds. You can see a simplified model with surfaces and rigid links here. Okay, then we can also take a look at the results on the surfaces. For example, here surfaces equivalent stresses, the sigma max Mises. Okay, and you can add dimensions here, and print it in the printout report. Okay, did I forgot anything? Well, I think no. Okay, that should be all to this connection. I switch to another RFEM window with other connections that we already prepared. You can use the plates behind the flanges here for such a rigid connection. So quite new is the welded connection of rectangular hollow sections. You can see where is the weld on the fillet missing. We are working on it. At the moment you are on the safe side. Only the straight components are connected. We are working also on the implementation of the round hollow section, and when we release it, I think also the welds on the fillets here are ready. Also such a connection. Okay, then other connections are, for example, the diagonals for a truss. Here's another connection. It's not practical to use different connections on one truss, but we would like to show the different options in that model here. Then, for example, maybe for the mechanical engineering, there are, for example, here a column base over a crossing of horizontal beams or such a crossing. You are very flexible with the single components, as I already said. Yeah, and just try it. Okay. Then I can give you a short outlook. As I already said, the add-on steel joints is constantly being further developed. We will extend the component and template library. As I already said, the round hollow sections, base plates, etc. Then we will integrate the dimensioning of the components. Then the calculation of the joint stiffness and the automatic transfer to the structure. That means an interaction between the connection and the structure is then possible. We will implement other standards, for example, the American standard, the export in the DXF file, and so on. Okay, that should be all for this webinar. We recorded this webinar. I would like to show you where you can find the recording on our website. On our website, dlubal.com, you can find the news and events here. And if you move the mouse at the bottom, you can see the webinars. That's today's webinar. We record all our webinars. You can see also the upcoming webinars next week, the FAQ webinar, seismic design, and so on. Just take a look on that page. So I open the event page of today's webinar. You will find the recording in the middle here, and you will find the models. You can see in the uploaded model, you can find also connections on the edges here and the other connections that I introduced. Okay, then I have to say thank you for your attention. Thanks to my two colleagues for answering the questions. Maybe last hint, when you leave the webinar, there's a small survey. You can score us. Just note that the worst score is 1 and the best score is 5. There are some questions, for example, if you have, if you wish some topics for future webinars, if you haven't wishes or you don't want to answer the questions, just enter a minus or something like that. Okay, I forgot something. If you don't have got the add-on or RFEM 6, you can download the free trial version here on our website. On the top, you can download the RFEM 6 trial version with all add-ons, also with the add-on steel joints, RSTUB 9 trial version, R section, R wind, etc. Okay, that should be all. I wish all a nice rest of the day and bye-bye.